Hello students. So today we're trying to finish up the properties of indifference curves. We were in the middle of the fourth one before the fire alarm started. So our fourth property was that the slope, or I should say more precisely, minus the slope of the indifference curve had a name, and that name was the marginal rate of substitution. The marginal rate of substitution is just MRS for short. MRS is a pretty ubiquitous abbreviation in economics. Not just this book, but in pretty much all other econ books, you'll see MRS, or marginal rate of substitution. So the interpretation of this is sorry, still not 100% here. Feeling a lot better than I did back when on last Wednesday, but still coughing. So let's just draw some graphs. So let's say around this point over here, maybe the MRS is 3. These two bundles, A and B, and two goods, X and Y. So here, your MRS is 3. So what that means is that if you lost 3 units of Y, so went down by 3 over here, but you gained 1 more X, you're still on the same indifference curve. So that means you're still equally well off if you lose 3Y but get 1X. So what that means is you're willing to trade 3Y for 1X. So the MRS is the willingness to exchange the two goods, X and Y. And the MRS has a further interpretation. So the MRS, that may have a different number, that'd just be the rate you're willing to exchange. If the MRS had been 4, for example, instead of 3, MRS had been 4, that means you're willing to give up 4Y to get 1 more X. And another effect about the MRS is that it's equal to the ratio of marginal utilities. So it's the marginal utility you get from X divided by marginal utility of Y. If we think about it a bit, this actually makes sense why this would be equivalent to this story over here. So maybe each unit of X will give you, let's say, 5 utils. each unit of y gives you 1 util. So you have to give 5y gives you the same amount of happiness as 1x. So we're going to trade 5y for 1x if those were the marginal utilities. So that willingness to trade is also equal to this marginal utility ratio. The marginal utility ratio is something we've actually seen before. Way back in chapter 16, we had this optimal consumption rule. So remember, the idea was we were trying to figure out what's the best a consumer can do for themselves while staying within their budget. And we said that rule was you had to have the marginal utility per dollar equal across goods. So the marginal utility per dollar is marginal utility of x divided by the price of x. So that's how much marginal utility you get, how much extra utility you get each time you spend $1 on x. That's equal for all goods, so that also has to equal the marginal utility per dollar you'd get from y. And we noted very briefly in chapter 16 that you could actually rearrange this. So you could multiply both sides by px and then divide both sides by MUY. And you get this. The marginal utility ratio was equal to the price ratio. But as marginal utility ratio, we said that's equal to the MRS. So if you put all this stuff together we've established here so far, you get this. So when you're optimizing, you have minus the slope of the indifference curve which is the MRS, which is also the marginal utility ratio, which is also your willingness to trade X and Y. And that has to equal the price ratio. So a lot of stuff we learned about earlier turns out to be equivalent. So that was our fourth property. Now I'll move on to property number 5. So I've been drawing indifference curves that look like this, and I hinted earlier there's a reason why it's this shape and not some other kind of shape. And here we'll learn about why that is. So that shape is convex. We talked about convex versus concave way back in, I think it was chapter 2. So the way we did this is you would pick 2 points on the curve, so like this one and that one. Connect them with a straight line. If your line is always above the curve, like this one is, then your curve is convex. If your line is always below the curve, like this, so pick 2 points, connect them, we call those kinds of curves concave. So a curve like this one would also be considered convex. So pick 2 points, connect them. Line is always above the curve. And just to show one more possibility, upward sloping and concave. That'd be like this one. So pick 2 points, they're always below the curve. This would be concave. We already established in our, I think it's the first property, that indifference curves are downward sloping. So now we're going to talk about why they look like this and not like that. So what it comes down to is diminishing marginal values. So back in chapter 16, I said diminishing marginal values was one of those super important things you'll see many, many times. Well, promise kept. Here is appearing yet again. So an example, you could look at, let's say, food and TVs. Let's call us points C and D. So at C, we have a lot of food, but we don't have many TVs. And diminishing marginal values, of course, will apply to both of them. So if you have a lot of food already, the marginal value of having even more food is quite low. If you already have enough food, if you have more than enough food, then that'd be a good idea to trade some of it for something else. So if you have more than enough food already, it makes sense to get rid of some of that excess food in order to buy a TV instead. So you want to give up a lot of food to get just one more TV. Means falling pretty far down over here. So give up a lot of food, getting one more TV. The slope is going to be steep. At point D, though, it's a different story. So here you have a lot of TVs, and if you already have, say, 2 TVs in each room, then having yet another TV doesn't make a lot of sense, especially when you're starving. So you have too many TVs already. It's better to give up TVs, even if you get just a little bit of food. Those extra TVs are just redundant, and you're pretty hungry. So at this point, you're very willing to sacrifice TVs to get food. So you're willing to give up a lot of TVs. This would be like a lot of TVs you're giving up. Even for just a little bit more food, just that much food, then the slope is going to be flatter. So if our curve starts out with a steep slope, where it's almost vertical over here, and that becomes almost flat over here, if it starts steep, becomes flat, that's going to give you a concave shape. If you tried a different shape for the indifference curve, that would not be consistent with diminishing marginal values. So perhaps you might have been wondering before, why aren't indifference curves just straight lines? Why can't that be my indifference curve? So you could have some point over here. Let's call this point E, since our last points were C and D. So at E, once again, you have lots of TVs, but not very much food. So if you're hungry or starving, you would think you'd place a much higher value on food than on having yet another TV. But if you draw your difference curves straight like this one, then person down here who has very little food and tons of TVs is just as willing to trade food for TVs as they were when the situation was flipped. So at F, you have plenty of food, not very many TVs, and now you want to trade food for TVs. It's still the same as it was back there. You're still the same slope. So because of diminishing marginal values, as you have less and less food, the more you're going to value it. The less food you have, the less likely you are to want to give it up. This straight line here, though, says that you're willing to trade. Your slope is still the same, which means that the willingness to give up your food is the same if you have a lot or if you have a little, which does not make sense. So diminishing marginal values rules out stuff like this. So that's why indifference curves are curved. They're not straight.